right, so as we discovered previously, we have these facts for our probability distribution functions. We don't need to memorize these, but we do need to be able to use them. So if I roll a regular die, I know my probabilities are going to be 1/6 across the board, and my mean was 3.5. So if I want to find the standard deviation, well, I could find it exactly using my formulas, or I could use my calculator. So let's go ahead and find it exactly. So I know standard deviation is going to be the sum of my probabilities times my x values squared. So all of my probabilities are 1/6, so that's going to end up just creating a common denominator of 6. And I'll have 1 squared plus 2 squared, 3 squared, 4 squared, etc. And then I'm going to have to subtract my mean, which is 7/2 squared. That's what my formula says. So I'm going to show you some shortcuts for your calculator to do this. So if I go into my calculator, I can put in my values. I can also put in the probabilities, so those are all 1/6. And the way that I got these quickly, I'm going to show you. So clear it out. I went up into list 3 and said list 1 values squared. So if I have all this data, so that's all my values there, I can then also come, so second stat lets me play with my lists. So under math, I have an option to sum the list. So I can do sum of list 3, and that gives me 91. So I'm going to end up with 91/6 minus 49/4. That's going to give me my variance. Of course, if I had my calculator, so 91/6 minus 49/4, and then I'm going to take that and turn it into a fraction, and I get 35/12. If I had my calculator from the start, though, I would just go ahead and use my 1var stats, and I can use my 1var stats with my, I'm going to do a stat calc. I can use it with probability data, no problem. So when I do my calculation, I notice that my n is 1. This is a nice way to help me check that I've got my probability distribution function correct. There was my mean of 3.5. Here's my standard deviation. If I want the exact value, remember I'm going to go into vars, stat, and take the standard deviation value, and then square it to get the variance, and then turn that into a fraction. And there's my same exact value. All right, let's see what happens with this example. So a die that gives 6 half the time, so its probability is a half. The other numbers equal probability, so I have a half remaining. Divide that by 5. Each of these is a tenth. All right, so find the mean and standard deviation. I'm going to go into my stat and edit my list 2. And there's no quick way to fill that in. All right, so let's repeat our calculations. All right, so now we've got a mean of 4.5. My standard deviation value is 1.8. Let's see if we can get that exactly. So vars stat standard deviation squared. And that's definitely an exact value. So we get root 13/2. However, seeing it as it's 1.8 helps me compare it here. This one was 1.7. So comparing the results, in this set of data, we're far more likely to see 6 than any other number. So our mean was higher. The mean up here was 3.5. And our standard deviation was greater because we have more numbers further away from the mean value.